Okay, so the second set of questions that didn't go quite as well as we'd like on the quiz, we're looking at meanders. So a quick question here, looking at a meander cross section. So I want to imagine you're sort of taking a slice through it and you're looking down the river, and what you can see here is you've got this classic sort of cross-sectional sort of shape of a meander. And over here you've got 5 statements. So you've got the outside being undercut by erosion, you've got slow water, suspended material, you've got sand and shingle on the inside of the bend, you've got faster water. All I want you to do is get a pen and a piece of paper, stop the video in a second, draw a quick sketch of this, match up the labels in the right places, and when you think you've got it done or you've got stuck, press play and we'll see what the answers are. Okay, so I'll pause for a second. Okay, so hopefully you've had time to have a go at that. So let's have a look at this. So let's start the first one. So the bank on the outside is being undercut by erosion. And you can see here's the bank, and you can see it being undercut. Okay, a bit like a plunge pool in a waterfall. The river here is eroding, here it's undercutting, and it's created what we call a river cliff. And you can see the label there. So look at the first one. Okay, goes there. Now, that erosion was happening because the water on this side is fast, and it's fast because it's deep. And the deeper the water, the less friction there is, the faster it's going to go. Well, the other side of the coin is that the shallower the water, the more friction there is, okay, the slower it's going to be. So if I just do this, slow water comes over here. Now you can see here where the mouse is, the sort of brown dots are. That's again in the fast water, because the water's going fast, it can transport stuff, and in that case it'd be like the mud and bits and pieces that are being transported, and we call that suspended material. So suspended material goes there. We've then got deposition of sand and shingle. Now rivers dump stuff when it goes slow, so it's going to be on the slow side of the river. We know this is the slow side. In fact, we can see the sand and shingle here. We call this feature a river beach or a point bar that's forming off here, or in fact, it's got lots of names. This one's called a slip-off slope. But slip-off slope, point bar, river beach, all are perfectly okay names. But that one, I think, in a second, is going to, there you go, goes over there. And even a muppet like me can work out that this one has to go over here, but it goes over here because it's the deepest water. Deep water means little friction means it can go really fast. So that, okay, is that diagram. So that's just going over a couple of things that we picked up from the quiz that you did, the online test, that weren't quite 100%. They'll come back up again, I'm sure, in the next quiz test that we set at the end of this week. So make sure you know those, guys. We really need to nail that before we start moving on. Moving on then, we're coming back to this. So we're looking at the sort of lower course. And the lower course, remember, is that bit of the river near the mouth, near the sea. Okay, and that's what we're going to be looking at today. And this is sort of a very simple diagram of what you're looking at. You've got a sort of floodplain, and notice that's very flat and it's quite wide. We've already looked at oxbow lakes in the last lesson, so we're not going to go over those again. We've got things called levees, which we'll look at, and then when the river reaches the mouth, we call it an estuary. So they're the sort of features that we'll be looking at. Now, what I'm going to do for the next couple of slides is just talk through some information at you. Now, all you can do, you can listen, you can pause it, you can come back to it. But when I've done it, I'm going to ask you to do a sort of mind map of this information. So let me talk through the sort of basic information. Then what I suggest you do is you stop, you have a go at mind mapping it, try and see what you can remember, go back if you need to. So when we're talking about an estuary, and sorry, a lower course, what we're really talking about is the bit of the river at the absolute bottom of the river, so the bit just before it reaches the sea. And as the river goes downstream, more and more water is joining it, and as a consequence, the river is getting bigger and bigger. So what you'll find is that the river is actually at its widest point, the lower down the river you go. Not only that, it'll be deepest. And actually, what's really interesting, okay, is that the gradient is actually going to be really shallow. We're talking less than 1 degree. But because the river is so big, and because there's so much water in it, and all the big rocks have been ground down to mud, there's hardly any friction. So actually, although the river is actually is going down a very shallow gradient, it's not going down a steep hill at all, it's almost a flat bit of land it's flowing over, it can actually travel really fast. And most rivers actually travel faster on average in this section than they do up in the hills on the steep sides where there actually is loads of friction. Now, we've already talked about the features, and you can see here the sort of floodplains. These are big flat areas next to the river. The meanders, you can see the bends in the rivers here. Just about make up some little oxbow lakes on the side here, but struggling to see really good examples. But what you certainly can do, you can start to see some of the sort of marshes and the mud flats where basically mud's been deposited, and that's really good sort of habitats for birds and sort of wading birds in particular. Now the other thing obviously is these rivers are really big, and these are big rivers with lots of flat land. So you'll often find sort of industry, factories, might be sort of chemical plants or power stations here, because boats can come up here, they can dock, and there's large areas of land. So often they have what we call industrial landscape. And the final bit is sometimes known as an estuarine landscape, and that's an estuary is where the river mouth reaches the sea. And this water here, in this particular image, would be a mixture of fresh water from the river and salt water from the sea. So it's sort of what we call brackish. It's a mixture, it's not either fresh or seawater. So they're kind of key features. Again, if we look then, there's two key features we're going to focus on. One is the floodplain, and again you can see here just how wide and flat that floodplain is. And again in the diagram you can see it here. And we're talking sort of kilometres across. Something like the Thames floodplain is tens of miles across either side. And in that floodplain, what you'll find is that when the river floods, it deposits mud behind it, that's silt, what we call alluvium. It's called alluvium because it's rich in aluminium, sort of aluminium silicates, and that's really fertile. So it produces this sort of rich, fertile land under the sort of floodplain, and that takes sort of thousands, tens of thousands of years to actually build up. And then the other landform we'll talk about, and you can just about see them here. We'll look at them closer again, are these things called levees, and these look like sort of raised, they almost look like man-made sort of barriers either side of the river, but we'll look at those again in a bit more detail. And the whole thing about this is that as the river meanders, you've got that mixture of erosion and deposition. And because it's happening sideways, it's called lateral erosion and deposition. So that's a really quick summary of what we're going to do today. And what would be really useful is if you now just draw up from memory, if you can, a really simple mind map of the features of the lower course. So what is it about the channel? Was it narrow? Was it wide? Was it fast? Was it slow? Was it deep? Was it shallow? What landforms were there? Were we seeing V-shaped valleys? What was the floodplain like? What was forming next to the river? Things like that. And what sort of habitats were being created and what sort of animals. So have a quick go and see if you can get 3 or 4 things for each of those. You'll struggle to get more than 1 or 2 things for habitat though, but see if you can get 3 or 4 things of these. And you can add to this as we go through from the video. It's always a really good sort of idea to get your head around sort of things to sort of mind map it like this. So I'll stop the video for a second while you have a go at that, and then we'll start looking at some of those features in a bit more detail. Okay, so what we're going to do now, do a couple of little exercises where we're going to ask you to think about the sort of processes and the features going on. And again, this is a cross section, so you've got to imagine that we've taken a giant slice through a river. And what you've got here, just try and give a little bit of perspective, is that that blue bit there, let me shade it in, is the river. Okay, so you've got your sort of river flowing there. And then this is the floodplain. And what you'll see is that you've got all the labels here. And all I need you to do is, if you've got the worksheet, you can just label it A, B, C, D, E. If you haven't got the worksheet, you probably do need to draw a neat version of this and annotate it. But I'll go through that, perhaps a clearer version of this in the next slide. So if you want to stop this and have a go at this, you're welcome to. If not, if you've, like I say, if you've got the worksheet, then you can have a go at that. And when you've got that done, come on to the next slide and we'll go through the answers. So like I said, this is perhaps a slightly clearer version of the diagram if you have to draw it from scratch. And what we're going to do is just talk through the different things going on. Now we're going to start off with this. Now that dotted line there, let me just draw it in red. That is called bankfall. And bankfall, as the name suggests, is when the river is right up to the top of its bank. It's about to flood. And when a river's about to flood, it's got loads of energy, the water's traveling really fast. And remember, water travels really fast when water's deep. So when it's about to flood, it's at its deepest. But as soon as that water goes over the side, it's no longer deep. It's really shallow. If you think about it just here, as the water runs down here and here, there's hardly any depth to it at all. It's going to go really slow. Slow water deposits. So what will happen is that as soon as that water gets over the top of the river, it slows down and it deposits. And it will deposit the heavy stuff first. So the biggest stones are deposited next to the river. And it's that which builds up to form a levee. Okay, and like I say, it looks like a man-made sort of barrier, to be honest. But we'll look at those again in a bit more detail. Now, once the water's broken over the bank, it will carry on flowing. And what you notice is that actually, if we look here, and look at the land. The land actually goes downhill away from the river, which isn't necessarily what you'd expect. But what it means is that the water will flow away from the river. So the water will then flow either side of the river across the floodplain. Okay, and that's why we've got that happening. Now, if the heavy stuff is deposited over here, okay, where C is pointing to, then the finest stuff, the silt, the mud, the really fertile soil, will get deposited over here. And you can see here there's crops growing and things like this. And this is often really fertile soil. Might not use it for growing crops because unfortunately it has a habit of flooding, but often is really good land for sort of cows and sheep and that sort of animal type farming. Okay, so the next thing is that you've got this sand and this silt being constantly deposited. Okay, you've got this what we call alluvium. Remember, it's aluminium rich soil, really fertile. And what that's going to do is going to build up the floodplain. And not only is it going to build up the floodplain, but as we've already said over here, okay, and I'm not really sure why this one, if I'm being totally honest, if you've struggled to find where this one goes, I don't blame you. I'm not sure quite why it's labelled there. It should probably be over here. But again, as the river floods, as stuff is deposited, the sides of the river builds up, but so does the base of the river, and the whole thing is just constantly building up. And basically, this process of deposition, coupled with the river eroding on the outside of meanders, is what causes this sort of very wide sort of floodplain that's characteristic of a valley in the lower course. So hopefully you can use that then just to correct anything you got wrong on that diagram. And then what we'll do is we'll move on to the next task, which is looking at levees. These things over here, C on your diagram. Okay, so what we've got a picture here is of a levee. So you've got the river over here and you've got the floodplain over here. And you can see you've got this really quite steep sort of ridge next to the levee. Now, I always used to assume that that was a man-made thing or some sort of flood defense. And actually, often people do build barriers next to rivers like this. But this is totally natural. This is a levee. And basically what happens is, here's your river. As the river floods, the water starts to rise up the bank. It gets to the top here. Remember, when it reaches the top, the side of the riverbank, we call that bankfall. And as it's going up, what's happening is that the river is actually slowing down because there's more friction. As that water's flowing across the riverbank, it slows down. And so what happens, and you can see here, is that because it's slow, Slow equals low energy equals deposition. You're going to get deposition, and it's going to be the heavy stuff, so you'll find lots of sand and bits of stone here. And then after the river's gone back down, that's built up again, and you've got these natural levees. So your job, using my explanation, using those three diagrams, using the writing on the left-hand side, I want you to draw a sketch of those three things here. Okay, read the description to help you as well as my explanation, and then explain how a levee forms. So have a go at that, and when you're ready, we're ready to move on. Okay, so we're coming to the end now. I just want to think about summing up where we've got to with this. So again, you should have this on your worksheet. If you haven't, I'm afraid you're probably going to have to write this out. You can just stop the video now and have a go. But what I want to do is use these words down here, okay, fill in the missing words, and that will just consolidate what we've been talking about. Okay, so I'll stop you for a second and then we'll go through it. Okay, so I hope you had time to get that done. So let's go through it. So an estuary is a place where fresh water, okay, meets the something. So let's have a look. Fresh water, a freshwater river, and you can see here there's the river, which is fresh water, meets the salt water of the sea. So hopefully that'll be the sea. A river usually flows through an estuarine landscape for its final few, well, yeah, we're going to use metric, could be miles, but we're going to use kilometers, one hopes, okay, before it reaches the sea. In estuary, the salty ocean mixes with a freshwater river, resulting, remember we called it brackish water, so hopefully we've got that, yep. And brackish water is somewhat salty, but not as salty as the ocean, so like I say, it's 50-50, or a rough mixture of both. The landscape of the river channel of the estuary is constantly something as the flow of the river changes. Well, again, it's a dynamic landscape. You've got erosion, you've got deposition, you've got flooding. It means it's going to change. The power of the something will vary daily. Well, that's going to be the tide. Okay, we know that you get high tide and low tide. But also the discharge. Now, discharge we'll look at in another lesson, but discharge is the amount of water in the river. So that will go up and down. Where the water is still, so it's almost stationary. So creeks, for example, sort of any backwaters, anywhere where there isn't fast flowing water, okay, you get the salt marsh form. And here, silt and mud, really fine sediment, will get deposited, and this can only be deposited when the water is practically stationary. The reason why this happens is that you've got salt water, and the sea actually encourages, it's quite complicated, it's called floccination, but basically salt makes mud, the salt particles cling to the mud and the mud sinks. So that causes deposition of the mud particles. Okay, and where you have got mud flats and creeks, they will be covered at high tide, but when the tide goes down, the river water goes down with it as well, because remember it's that sea and river water, and so they'll then be exposed. You'll be able to walk on them at low tide. So that kind of sums up, if you like, what's going on in an estuary. Okay, so that's the end of the lesson. And just a really reflective bit, actually. It'd be interesting to know how you've got this. So just, you can do this perhaps in your head or on a piece of paper. Just reflect how you are. You know, is it that actually you are just, you know, I don't know, particularly angry and annoyed and we haven't covered something or we haven't explained anything? Are you actually thinking that, I don't know, you're an absolute angel because you've actually done it, or is it one of frustration? Are you happy with it? It'd be really interesting to know where you are on this, okay, and why. And if you want to let me know, that's absolutely fine. Hopefully that's explained those two things for you. If you can get this done by the end of the week, that's grand. We'll set the next piece of work later on this week, and that'll be due for Monday. There isn't an explicit test for this one. We'll cover that when we cover the second lesson, and so that test will probably be in on a Monday. But if you get this done, that will be grand. Right, well, I hope this has been useful. Any questions, any concerns, anything you're not sure about, please email me. And like I say, it'd be really interesting to know what your thoughts were about this lesson. Right, well, Thank you so much. And like I say, any questions, just contact me. Cheers.